Hello and welcome to part 2 of the Java programming language course. So in the previous tutorial we learned the basics of Java, how to compile it, how to fix errors, how to debug it, how to create objects, classes, and in this tutorial we will keep learning about these concepts, but we'll also learn about data types, integer and floating point data types, right? Okay, so if we continue experimenting with these, we have created a dog, then we have created a dog with name, then we have created we'll set the age of the dog, and then we call barking, right? So if you remember, if we compile the code and if we run it, it says hello world and then it says barking, which is exactly what we actually want. But now, how can I know if the age that I set here actually took effect or not, right? So I am calling this method right here, the int age. I will set it to my dog that get age method, which if we go back to the dog class, what this get age method will do will return the age of the dog, right? So we will print this to check if it's indeed 10, okay? So to print it is very simple. So it's basically we say, and we call system.out.println, right? And inside here we will pass the thing we want to print. In this case, we want to print an integer. So to transform from a integer to a string, maybe we can do the following. So if we do nothing and just pass the age right here, right? And if we compile it and then if we run it, then the compiler is kind of smart enough. The compiler is smart enough to transform these into a printable way, right? So as you can see, it has the 10 value right here. So the age we just set right here, it's actually working. So if I comment this and I run it again, okay, then it is set to 0 because the default value of an integer is 0, right? But what if I want to set the age in an alternative way? How? Well, basically saying my dog dot set age, and I will pass 10 right here. Okay? So if I compile this and run it, I have 10. So here notice that we have two ways of accessing um, class members like the age, right? We can either do and say my dog.age is equal 10 or my dog.setAge, and we will pass the 10 value right here. So this is how we can basically call two things in a different way, right? In two different ways, right? So this is basically how this works. Now we will go and start learning about primitive data types. So we will start with integer data types. So after these multi-line comments, I will start writing how the data types in Java work. So we have the smallest one is called a byte, right? So a byte, I call it my byte, for example. I will set it to 0. So I will put a comment describing what a byte does, and this basically can contain different ranges of integers. So it goes from negative 128 to positive 127. This means that my byte variable can contain 256 possible values, and those values are between the ones I just specified right here, inclusive, right? Then we have a short. So short, I will call it my short. So all of these variables enable us to store numbers basically. So byte we can store kind of small numbers, right? With short, we can store a bit larger number, right? I will set it to 0 too. We can set it to 1000 maybe, because we really are able to store larger numbers in my byte, in my short. But in my byte, we cannot go beyond 127. So the largest number it can have is 127. So then we have my short. And the short data type is able to store values from the range starting at minus 32,768 to 32,700 and 767. So it can store kind of 65,000 different numbers, okay? And we have also larger, like int. So an integer can store larger numbers, right? I will call it my int. Now we'll set this to 100,000, right? And what these can store, they are really big values. For simplicity reasons, it will start with negative 2 billion to positive 2 billion, right? And those are pretty big numbers. The integer is the most commonly used data type. As you can see, I used it to define the age of a dog. I used it to define basically the age, but that's how we use an integer. So integers are just numbers, right? And then we have longs. Well, a long is an even larger one. I will call it my long, and this is just insanely large. So it goes from, I don't even know how to pronounce it, so let me see if I can actually figure out what this number is. So we have, let me see, million, billion, trillion, quadrillion, quintillion or something. I don't know, it's a huge number. So you can really store very large numbers in a long, which it's very hard that as you learn, you will be using those numbers, right? Okay, so it says that the literal of type int is out of range, but that's because the default way that the Java program handles large numbers is in integer. So if we want to cast these as a long, it will be better understood by the program. So is this too large for a long? I don't think this is too large for a long. So maybe the problem here is that the thing of Visual Studio Code is not working as it should, right? So that's why this warning, we will ignore it because it's a kind of a bug of the system, right? So this is insanely large numbers. Oops, insert insanely large numbers, right? So that's what a long is able to do. Okay, just to make sure I didn't type an error, I will compile javacode.java, and it says integer too large, right? But somehow the thing is that it should fit here. Okay, we will figure this out later, but we will decrease this a bit. Okay, we will put it in 10 million or maybe 100 million or a billion even, right? So now if we write it again, it won't say anything. So it says integer number is too large, but well, I don't really know why this is, but it shouldn't be the case. But anyway, so long, we can store insanely large numbers, right? And we also have a char or a char, which is basically to store letters, right? So we can store different characters like and letters of the alphabet or whatever characters we may want. So I'll call it my char. And to store a character, I have to do it between single quotes. For example, I put in R, for example, capital R, and that's my character. So how many characters, how many possible values these can have? Well, a lot actually. They can have 65,535.36. So actually it goes from, it has values from 0 to 65,535. So this is basically how we can define these different integer data types that will enable us to store numbers, or in this case, a character, right? So let's compile it to check again everything is still working, okay? And yeah, it's still working. Now those are kind of these basic data types. And what can we do with these guys? So first of all, we can compare them, right? So we can check if a number is equal, smaller, or larger than another one. So to do that, we say if my byte is greater than 2, for example, and if that's the case, we will print something like, for example, print ln. Oh, I'm forgetting something right here. So system that out that print ln, and I will pass my byte is greater than 2, right? So if I run this right now, so let me check. If I run this right now, oops, we have something here. Okay, what's going on here? Let's check this again. So it says Java code that Java 36 illegal start of type. So why is this happening? So let me see. So here we have a problem. Token expected after this. So maybe here in the char we're having a problem. I don't really understand these. Let me check. A char. Okay, maybe this line is somehow causing a problem that I don't really get it. If I comment this line, just to make sure, then we'll still have some sort of a thing right here. And I'm just asking if my byte is greater than 2, then do just that. But apparently it's not understanding what I'm trying to say. I don't know why that is, but okay, if my byte is greater than 2. This is kind of strange to me, right? Okay. So maybe it's about the byte. So what if I go and test with my int? So if my int is greater than 2, and again, it's a problem. So if my int equals 2, and we still have a problem. And as you can see up here, we have an error token expected after this token, right? So maybe we have created an error. Oh, the problem is very odd actually. So we have to execute all of this inside the main method, right? So it won't work if we are executing it outside the main method. So we will move this code to inside the main method because we're kind of executing outside the universe, right? So we have to put it inside the main method right here, okay? And now I will go back to the original code, which is my byte. If my byte is greater than 2, okay, we compile it, and now it is working and it says my byte is greater than 2. So this we can set to greater than 2, we can set to smaller than 2, and for example, if we set this to 1, if my byte is set to 1, and I will say my byte is less than 2, okay? If I compile it and I run it, it says my byte is less than 2, okay? So basically, this is the operation we're performing to compare if it's smaller, larger, or maybe equal to 2, okay? And we have smaller, larger, we have less or equal than, okay? We have also greater or equal than. So just these are the basics, and we have also different. So if my byte is different than 2, so this is what the different sign means, right? So that's basically, we can also perform operations right here, right? So we can, well, let me delete this, and for example, we can start doing additions, for example. And if I go and say for example, I will add 2 numbers, okay? So let's create an integer, and I'll say sum, and I'll set this to my int plus 6, right? Okay, so that's how I create an addition. And now if I want to print this, I'm gonna say system dot out dot print ln. Okay, I open this and I will print sum, right? So if I go ahead and compile this and then run it, it says the number of integer, which was 100,000, it now is 100,006 because I have added 6. Okay, we can add, we can subtract, we can multiply. To multiply, we use an asterisk. We can divide. To divide, we use a forward slash. So that's how we divide, basically. Okay, so yeah, so this is the basic operations we can perform. We can also have the modulus operator. Modulus operator is used with the percent sign, and what this does is basically it returns the remainder of a division. So it will divide my int by 6, but will return the remainder of that division. In case it's 0, it will return 0, right? So basically that is how these variables work, but we don't really have to perform these operations here. We can perform them when we print them, right? So instead of printing sum, for example, I will print my int times 3, right? So if I go and compile it, okay, and I run it, it is 300,000, right? Because it's 100,000 times 3, it's 300,000, right? So that's how we can do this, right? Now let's take a look at the floating point variables, right? So basically, what is a floating point variables? Well, it's pretty simple actually. A floating point variables enables us to store floating point values, right? So the most basic one is called a float, right? So you're gonna say my float, and here to specify a float, I will specify to 1.45, 1.45, okay, and I will print this out. So you're gonna say system that out that print ln, okay, and I will print my float, okay, and I will compile it, and so we have an error here. So to end these, we will end with an F to let the compiler know we are actually defining a float, right? So we compile it again, and now it compiles, and as you can see, it prints 1.45, which is exactly the number we want. So the previous ones were only for integers, and these ones are for floats. So the first float is this, which can kind of 6 possible decimal values. Okay, so if we add more decimal kind of precision, we also have them here. But if we want something beyond that, we have to create a double, so if we, which is a double precision, right? So you're gonna say double my double, okay, and we will set these to 1.345654345 or something like that, okay. And if we define this, we will compile it and we will run it. And I forgot to print this, so let me print this. So you can say system.out.println, and I will pass my double. Okay, so this is how we will print a double. So we compile it and we will run it, and here is how we have double precision floating point values, right? So that is how we can do this. So apart from the operations I told you previously, we can also decrement by 1 or something. For example, if I want to increment my byte with 1, so I want it to be 1 plus 1, how do I do it? Well, the first option would be my byte equals, which is assign my byte to my byte plus 1, okay, so which is kind of the easiest way to figure it out. But we can also have the following way, and we can say the Java language enables us to say my byte plus equals 1, right? If we want to add 2, we will say plus equals 2, right? So both are, these two do basically the same, just it looks different, but do the same. Now, if I just want to add 1 in a simpler, even simpler way, I would say my byte plus plus. So, which means increment the current value of my byte to 1, by 1, right? So, if I want to decrement it, I would say my byte minus minus, right? And it will decrement. So, right, this one is pretty useful, the second option, because it can be used for different operations. It can be used for division, it can be used for multiplication, for modulus, whatever the case may be, right? So that's how we work with these new operations. Okay, we also, apart from these two, bytes and shorts, integers, floats, doubles, we also have a smaller kind of a variable, which is a boolean. So a boolean can either have on or off values, so it can be true or false, right? So boolean, I will call it my boolean, and I will set it to true, okay? It can be either set to true or false. This will enable to check some conditions. So we can say if my boolean, okay? When we say if my boolean, we're asking if my boolean is true. And if it's true, we can execute some code. So execute some code accordingly, right? And if it's false, we can do something else, right? Whatever the case may be in our program, so do something else. So that's where booleans can be used for, right? So pretty easy so far to understand these concepts, right? The booleans can also be checked with the same as we did previously, right? Okay, so we have learned objects, we have learned classes, we have learned data types. Okay, we have learned how to print some stuff to the user, and basically that is kind of the basic ways to learn how to program in Java. Now we will learn a bit about methods, right? So let's create a method that will enable us to kind of practice how this will work, right? I will leave the doc class there for a moment because we may use that later, but then I will delete all of these other stuff inside the main method, right? So don't forget to close the main method. Okay, and inside the main method, I want to call another method, right? So maybe I want to call a method that would say add numbers, right? So and that addition will return an integer, right? So you can say int add numbers. And now I will introduce you to parameters. So parameters are values like the ones we used here in the doc class, or these inside the parentheses int age, right? So are values that are passed between method calls to specify what do we require from the method, right? So for example, the first one will be an int that I will call n1, and to separate parameters we just put a comma. The second parameter will be an int again, and then 2, right? So we open this, and what we will return here. So when we say return, it says go back or send back something, right? So what we will be sending back will be the addition of n1 plus n2, because this is called add numbers, right? So we will return n1 plus n2, right? So how is this even useful? Okay, so from inside the main method, we're gonna create an integer, and I will call it sum. And I will set this to the following thing. I will set this to add numbers, okay? And I will pass as parameters 1 and 5, for example. So what this is doing, it is saying add these two numbers using these two parameters. So as you can see, we have a warning right here that says cannot make a static reference to the non-static method. So as you can see, this method is a static, but this one is not. So we cannot mix them both, right? So in order for us to be able to access this, we have to make these static. So I'm gonna make it static, and now the warning has been disappeared, but now we have another warning right here that says token on static delete this token. So let me see. So this is basically because we're using this main method that is kind of mixing us with this. So we don't say first int static, right? We have to say static int, right? Static int. And that is how we define a method. So first, you have to remember the order of the operations we want. So first, we have the whether it's public, private, or protected. Then if it's a static, we will use a static, right? And then we will use the data type. In this case, is an integer, and in this case, is void, which is absence and doesn't return anything. So now when I call the add numbers method and I pass the parameters 1 and 5, then this one will be moved here to n1, and this 5 will be moved here to n2, and these will return n1 plus n2, and that result will be stored in the integer sum. So by the way, you have to receive the same type you're asking for. So if add numbers, when you say add numbers, it will return an integer, okay? So we have to store that result on an integer too. So after we get the sum from the method, I will print it by saying system.out.println, okay? And what I'll pass to this method will be sum, okay, because I want to print the sum. I open the terminal and I type javac javacode.java to compile our source file, and then I type java code to run it, and as you can see, it prints the number 6 because 1 plus 5 is 6, okay? So now in Visual Studio Code, that is a very useful tool to use. If you press Ctrl+Shift+I, it will format the document to make it more visually appealing and more ordered and structured. So that's a kind of useful tip too. So basically, we have learned a bit more about objects, a bit more about methods, a bit more about floating point values. And that's it for this video. I hope you enjoyed it, and I see you in the next one. Bye.